Hi guys, hope you are doing fine. So last day we talked about caching. We will be discussing cache eviction policies, but before that, we will have a small look. The reason we use caching in algorithm is typically to avoid reducing the same operation, especially computationally complex operation that might take a long time to finish. So and that also occurs multiple times. So to avoid these kind of situations, to enhance the performance, to reduce the network calls, we use caching. We have already seen that in our previous lecture. So we would caching to improve the time and complexity of our algorithm, to speed up our algorithms. And the context of in the context of system design, caching is actually pretty similar, as we already have seen. And we can say like we can speed up our system, and caching is used to also reduce the latency of a system. So before we move ahead, we have already discussed one important thing, that is called cache invalidation. And that cache invalidation talks like, if we have a server and if we have this cache memory, and this server data has been updated, and if cache memory doesn't know about that, then we need to prepare, or we need to use some techniques to understand that both are in sync. And we need to use some techniques so that we can update our cache accordingly. So we have already seen there are three techniques in the last lectures, and we have also draw something, understand it. And now we will be focusing more on the cache eviction policies, which where we will today we will discuss on last recently used stuff. So LRU is one of the important mechanisms which has been which contributes in the cache eviction policies. And what is that exactly? Okay, let's have a look on this. That is, first of all, like, as we have know that cache memory is very expensive in nature, as it uses RAM. And as it uses RAM, so it's very faster as well. But we don't keep all the data, our data into our cache, right? So we only stores those data which are relevant in terms of our enhancing our performance, in terms of reducing our calls, and which makes our which helps our intention, which is to speed up our systems. So which should be there and which not should be there, there should be some logic. So LRU actually gives us an idea uh, based on some methodology, like, yes, this should be first, needs to be kept, and this should not be I mean kept into the memory. So he gives, or this technique gives this kind of guidelines. So what does talk about? It also says like, whatever the gate operation we will be doing on our cache, whatever the put operation we will be doing on our cache, that will take big O of 1. That means the time complexity is going to be constant, so it's very efficient. And how it is happening, we will have a look on that also. Let's get into the detail. First of all, it's a queue based mechanism, or you can assume it's a queue based mechanism. That means the first item which comes will be added at the beginning, and whenever the next item will come, will be added at the first. And this item is going to be relatively obsolete than this item, the item which has been added newly. So if any other item comes which is for an example 3, this is 2, this is 1. So first item added is like 1, then 2, then 3. So 3 is going to be our most latest most latest item, and 1 is going to be the most oldest item. Now if we want to delete anything, so we will delete the most oldest item, because this is oldest in terms of that is least used item, right? And this is the current used item. Now the question is, here naturally you can see like there would be two pointers. One is going to be your head pointer, another is going to be your tail pointer. So two pointers is going to point these two items, which is going to be the most recent item and which is going to be the least recent item. Now how you will define that least recent item? That is actually based on the operation. Suppose we have any three items, and if we want to bring another item which is the new item, so the least recently used item will get deleted. So if 4 comes over here, so 4 will be added at the beginning, and then 2, and then there will be, sorry, then 3, and then there will be 2. So 1 is the least recent item earlier, so it will get deleted, because assuming we are making the size of this cache is 3. So this size is often termed as capacity. So we can say like capacity of the of our list, if it is become 3, which is actually basically the size, then this is, in this case, the least recent item 1 is going to be deleted, and 2 will come over here, and 3 is going to here, and the newly added item 4 will come here. Now you will have one question. Now you can ask me like, I'm going to add it over here and no element, I mean I can understand the order pretty well, but if I want to read something, from the existing item, then how will it behave? Suppose I want to, you can say like, I want to read the item which contains 3. So how would the list would like to be after reading this second item? Yes, the question is, as you are doing some operation on this item, so this item is going to be the most recent item, so the 3, this will come over here, and then there will be 4, then there will be 2. So this is going to be your result, because 4 was the, previously 4 was the most recent item, so it will it will come over here, and the, as you made some operation on top of 3, so 3 will come over here. So 3 is going to be your most recent item, and that is the least recent item. So if you want to bring something new, say for example you want to bring 5, then your list will look like 5, then 3, then 4, and you have to delete the least recent item. That's why 2 will get deleted. So that is the fundamental stuff. Now if you want to make it in O of 1, that means whatever you are reading, that means get operation, whatever you are writing, this, okay, let's talk about this write a bit more. This write is not only adding a new element into the queue, but also you can update an existing element into the queue as well. So that is the contribution of put towards this LRU cache. Now the question is, suppose as I mentioned, like if you are being asked to make it in O of 1, how would you like to do? So first of all, in general, like the whatever in case of hash table, this comes very easily when you want to get something. So if you want to read some data with the help of the key value, with the help of this key value nature, and you can get the value with the help of key, so you made that thing in O of 1, that's perfect. But when you are adding something, when you are deleting something, when you are bringing something in front, so these operations involves a lot of complexity. So in that case, probably when you want to delete something from the beginning, then, or something from the end, then doubly linked list would play a great role, right? So if you have a doubly linked list, and that means your every node has 2 pointers, and you are connected over here, so head pointer and tail pointer, or you can delete this pointer, you can change with the help of your head pointer, you can make an alternation with the help of your tail pointer as well. You don't have to face any issues. So doubly linked list, now what would be, I mean, how will it be if you have a hash table, and say for example you have a key, over here, that is 1, and you have a value over here 1, and 1 is the object. For an example, you are keeping it into your every node. Then 2 2 3, you are keeping this data in one of your nodes. So 2 2 3 3 3 4, these are your values and keys which resides in your node, and these are the keys. For an example, 2 2 3 3 3 4, you can see that. And along with that also, you are keeping some address, keeping address of this node, keeping address of this node, keeping address of this node. So you have the address and you have the value as well as your key. Now if you want to make any operation, you can directly go to this address and you can make changes. You can directly go to the address. So your put operation is also will be performing in O of 1. So that is the benefit we are trying to get over here, and that's why in this way we can move ahead. Now let's see an example. Suppose you have something like 1 1. So how will it look like? You can just say like 1 1 is to be at the very beginning. You will have a head pointer over here, there won't be any node, there will be a head pointer, and here it is the tail pointer. You will give me the answer. Next you added 2 3 for an example. So 2 3 will come very fast. Okay, let's assume like you have the key like this, you have the value like this. So in case of 2 3 it looks like this. In case of 1 1, your key is like this and your value is like this. This is your node. So 2 3 will come first. So 2 3 has come first, and then 1 1. Next you have like 3 4. So 3 4 you will come first, and suppose you have a capacity 3. So you cannot extend your list more than that. So now what happened, you got 3 5. So you are making change on 3 only. Actually I have just forgot to bring that thing. 3 5, if you made it, then on top of 3 4, it is going to be 3 5, right? Okay, so now let's you have get 1. So you did get 1, that means this one will come first, and then 3 4, and then 2 3, right? As we discussed earlier. Then you might get 3. So you will see like where your third key is there. Your third key actually is in this position, so it will come over here, and this key will come over here, and it will remain over there. So this is your least recent used, this is your most recent used. And then again 1 9, you adding it means you have to okay, you have a key 1 over here, so you are just adding it. So 1 9 come over here, and this is going to be here, and 2 3 will remain in the same position. Next 12 17, put 12 17. This is 1270 is the new node, so new node will come over here. This is going to be in the second position, this is going to be in third position, and this is going to be deleted, right? So in this way, now suppose you were want to get 30, which is not present here. So you can return null, or you can return -1. So in this way the whole eviction policies works. It's a very very important concept, and you need to, if you want, you need to write code. It has been asked in many organizations interviews session as well. So if you have any comments, if you have any doubts, please put it into the comment section. Hope this video will be effective. Thank you so much.